my name is Avi. I'm technical marketing in MELLANOX Technology. You're familiar with MELLANOX, by the way? No, it's first time, right? Cool. So MELLANOX started in 2000 as an HPC company. We built products for HPC. It means that we're basically doing InfiniBand. It's another protocol. We started with the silicon, NICs, switches, and the demands of the HPC customers like NASA, like universities and other, are that the products will be non-blocking, high performance, low latency products. And basically 6-7 years ago, we just took the advantages of those concepts and moved them to the Ethernet. And with this 30-minute session, I'm going to talk about the blocking block, the demands that we see today in the cloud, in the OpenStack clouds, and clouds in general, and the building blocks that we are providing, moving to solutions, and especially around how we can make it more efficient and reduce costs. So first of all, about the demands. The first demand that I want to talk about is bandwidth. Now, everybody probably understands that there is a problem with data. Data is exponential. It's just growing without stopping. Now, everybody knows that because everybody is using the iPhone, right? Taking pictures, posting them on Facebook. And, data is growing. There are reports, for example, that until 2020, we cannot manage anymore the quantity of the data. And more than that, storage devices are starting to be very, very fast. So if at the beginning we had spinning disk and we needed 250 spinning disks to utilize a 100 gig link, moving forward to SATA we reduced to 24. Then with SAS, 10 SAS only for 100 gigabit link. And now with NVMe only 4. So only with 4 cards of NVMe flash, we need 100 gig at least to utilize the storage capacity. So bandwidth is a demand. Also, we are moving to an era where we are doing cloud and what we called scale out. The difference between scale out and scale up is that in a traditional way, scale up means that you probably had 2 big Cisco chassis, right? You paid a lot for those chassis, maybe didn't use all of the ports that you had there. Traffic was moving from bottom to up, right? So traffic was going like this. Scale out means that now with you are building your building blocks are leaf and spine switches, right? So we are basically putting the number of leaf switches that you need for the number of the ports you need. You're doing the spines to do the interconnect between them. And the storages are in computer just everywhere. They can be everywhere. And that means that traffic is now moving east to west, right? So traffic is moving like that. And that means that the bandwidth that you need between leaf and spine is bigger now. Let's say an example. For example, if you have 10 servers that are doing 10 gig and now they're pushing 10 gig up to the spines to one direction, you will utilize 100 gig. It can happen. And another demand is to reduce the cost, of course. And reducing cost means that you need to have some kind of an umbrella of solutions to do that. So first of all, if you are getting up efficiency, cost will reduce. This is more related to OpEx. Power, for example, lower power mean lower costs. Being open is not a word. Being open means you need to really do it. And once you are open, you can provide the flexibility on your software to choose other solutions. And unique solution on the hardwares, like the switch that I will present in a minute, also can help reducing costs. And now I will talk a bit about the building blocks before going to the solutions. So CloudX is not a product, it's a recipe. Because MELLANOX is integrated in so many clouds over the world as part of the networking, we achieved some knowledge about the way we think, at least, a good cloud, or the way to build a good cloud. And what we did is build some kind of recipe. This recipe is not 100% or 0%. You can choose to use from this recipe what you think is good for you. And the building blocks of CloudX is, first of all, our end-to-end portfolio. So end-to-end means basically that we are doing NICs, Our NICs are doing from 1 gig to 100 gig. So it's 1, 10, 25, 50, 40, 100. We're doing also cables. We're doing switches from 1 to 100 gig. We have switches of 10, 40 gigs. We have switches of 10, 100 gig. We have switches of 25, 100 gig. We have switches that you can choose whatever speed you would like to have. And end-to-end basically means that we're doing the whole flow. You don't have to use our product everywhere. You can use our switches, NICs. You can use other cables. We are open. We are not locking everything. This is what differentiates us from other network companies. To make sure that we are working, we have a huge lab in Israel. This is my homeland, where basically we are buying all the products, relevant products in the market, and connected to them to make sure that we are working. End-to-end means also that we are doing software. So Neo, for example, is a free software that we are providing that provides fabric management, means monitoring, congestion control, counters, provisioning of the NICs, of the switches. And we are also giving the choice of the operating system on the switch. So we have our own MELLANOX OS. It's run for 6 years, run good. You have layer 2, layer 3 capabilities, OpenFlow, other features. Cumulus Linux is another option over our switches. My colleagues from Cumulus Linux are here. You can run Cumulus Linux on over our switches and enjoy the power things that Linux can offer. You can, by the way, switch between them. You can start with Cumulus Linux, decide you want to go to the traditional Cisco-like CLI or industry-like CLI web UI concept, and you can just switch and move to another. And we have also other operating system running on our switches. For example, Microsoft Sonic is an option, and other operating system that we offer. End-to-end in MELLANOX doesn't mean only right to left. It means also vertical. It means that if you take a product that we have, a switch, we are doing our own silicon. It is called Spectrum. This is what differentiates us from all others, because basically, if you take our competitors, they are using the same Broadcom silicon, mainly in all other products. So the way that we can compare ourselves to other companies is just compare the two silicons to show, look, we are doing better for performance. We are doing the system silicon software. Also on the NIC side, we are doing everything ourselves. It's very powerful. It means that basically once even the product is deployed situation, we can easily and in agile way do some changes or understand the problem because they see with the entire picture. It's not like we need to call Broadcom for the silicon problem or the system. We need to call Acton or whatever. We're doing everything ourselves, so we understand the full picture. When it comes to the switch product, we have the usual 32 ports of 40 gig. You can split to 64 ports of 10 or have 100 or the product of a 100 gig, which is 32 ports of 100 gig. The traditional top of rack with 48 ports of 10 or 25 and uplinks of 40 or 100. I didn't mention 50. This is also an option. In general, basically, you can take our switches and choose the speeds that you would like. If you want to use this switch as 1040, you can do it. If you want to use it as 10100, you can do it. By the way, we are giving 100 gig actually for free. It means that you are buying a 1040 gigabit flavor of this switch, but we are basically giving you 100 gig. You can use it if you would like. There is only advantages of having 100 gig actually. Everything is backward and forward and future backward compatible and future proof. When it comes to cabling, you can use the same cables that are connected to the 10 gig NICs that you are using today, basically, and connect them to this switch, which is 25 gig. It will work. The reason is because the 10 gig is SFP. This is SFP28, the same physical structure of the cable. This is an example. This switch is an example why we are unique in this market, because we are doing end-to-end. As I said, we are doing silicon, everything ourselves. Nobody else can do it. Nobody else did it. We have the ancestor of this product, which also in the market, and nobody else did it. And the reason is that because the first thing that you need to make sure it will be cost effective, right? Because when you are buying this switch, you are buying this switch for X dollars, for example. Your assumption is that this switch will be X, half of the price, right? Half of X. And to make that happen, basically you need to control the entire solution, because with our competitors, they need to go to Broadcom, for example, and say, okay, we need a discount. the silicon is the same here and here. Okay? So from the business perspective, you can do it. Also from the technical perspective, you can do it again because we have the entire picture. This is 16 ports of 100 gig. We also have the same flavor as 40 gig. And you can split all the ports. And let me give you an example what it's kind of an ideal top of rack. When you're putting two switches above your top of rack, let's say you have a rack of 40 servers of 10 gig. Kind of medium-large rack. I'm picking a large number to show you that this small switch can do basically everything. So you are taking 10 ports of this switch. There are 16 ports, right? 10 ports, you're splitting them by 4. So you have 40 ports of 10 gig. You are connecting each server in dual link. One is going here, and one is going there. This is called an MELLANOX structure. This is the HA on the top of rack. So we use 10 ports, connected all the servers. We are taking 2 ports. We are using the powerful 100 gig that we have. So we are connecting both for the MELLANOX, and we are left with 4 ports of 100 gig. Now guess what? 4 double 100 is 400 gig uplink. And here we also have 10 by 4, which is 400 gig downlinks. So with this small half width switch, basically we're doing non-blocking for 40 servers. We have 400 gig up, 400 gig down, MELLANOX HA, everything in 1U. And the cost is close to 1U. So this is kind of one of the powerful things that we can offer. Regarding the operating system, we are part of the OCP concept. So OCP basically talks about hardware, how exactly hardware should build, size, and so on, and also software projects. For example, MELLANOX that I mentioned is a proprietary protocol. We put it on GitHub. We're just saying if you want to do MELLANOX on MELLANOX, you can just go to GitHub and see. Size and NAS concept, where basically we pushed with Microsoft, and they said basically we're going to run our OS over MELLANOX, but I would like the choice to move MELLANOX and move to Broadcom. They cannot do it because they are running an application on something that is called SDK. This is the API that is controlling the silicon. But the SDK in MELLANOX is different than SDK in Broadcom. So the way to do it is basically build an API that is a standard for all companies, all silicon companies. So we pushed for it because we think that Microsoft will choose us. Eventually, they will not move to Broadcom, and we were successful by that, by the way. We think we did pretty good in this way. So now there is an API that is standard for silicons. ONI is mandatory for open network because it gives you the option. It's kind of a pixie boot for switches. It gives you the options to switch between OSs. This is why I said you can use Cumulus Linux, move to MELLANOX OS if you would like. If you are more kind of traditional team of people that like CLI and WebUI or whatever, they can use it. If they are more Linux, they can use Cumulus Linux. Cumulus Linux is our latest addition when it comes to choosing operating system. We have several more. A word about Cumulus Linux. Cumulus Linux can run over several hardwares. They are called white box. White box means basically that the hardware company is providing the switch. Cumulus Linux are providing the license. With our solution, we are providing Cumulus Linux, and this is the difference out of the box. It means that you are buying our switch, opening it, and if you would like, you will have Cumulus Linux on it. And also, the most important thing, we are the only focal point. It means that if you have a problem, whatever, software, hardware, silicon, firmware, whatever, you are calling MELLANOX, we will solve it for you. If we have a problem with Cumulus, we'll take it with Cumulus. It doesn't care. The Cumulus doesn't care. Customer doesn't care. He needs to call us. And this is a big difference between the white box concept that we have, example, H-Core and so on, where there, basically, you are calling the hardware company if you have a hardware problem, and you have support contract for that. And if you have a problem with the software, you need to call Cumulus. Okay, so we have kind of two heads to the support. I will skip that. This is just in 2 words. This is, as I said, what differentiates us from other companies. We are doing our own silicon spectrum. It shows better results when it comes to not losing packets, or when it comes to be fair on the buffers. We are doing 16.6 megabytes buffer, the same number that Broadcom are doing, but we are really doing shared buffers. So it means that every port are getting the same slices of the buffer. Here you can see Broadcom are not. There is some situation where when there is a VM connected to a port which is very happy is getting more buffer than the others. There is a report, it's a third-party report. We have customers that saw this report and said we want to test ourselves, do the benchmark ourselves. They did, they got the same results. Very surprising results, to be honest. But again, this is public, and you can also come please to our booth and can share some more information about that. So those are the building blocks. And when talking about solution, there are many solutions, especially around OpenStack, but I will touch 3 major ones. First one is the overlay. So I would say something like that. To run overlay, or maybe I would change my words. To install a platform or infrastructure which is 100 gig, it's not enough. You will not utilize the 100 gig or 25 gig. It will not happen. The way to utilize those speeds is only if you have the accelerations on the NICs. Why is that? Because what happens is that in a traditional NIC, for example, if you are using VXLAN, when the packet hits the server, the NIC is looking at this packet, doesn't know what to do with it because the packet is encapsulated. So what it does is push it up to the software. Once you are pushing something to the software, you are putting performance down. So with our NIC cards, ConnectX-4 or ConnectX-3 Pro, basically we have a feature that is called VXLAN offload. It's a hardware feature where our NIC cards do understand is pinning out the outer headers and being able to go to the inner header, do the checksum, do the RSS, all the functionalities that need to be done on the packet and move forward. So this is a graph where you can see that physical bare metal VLAN scenario versus VXLAN with offload, it's almost identical. But if you are removing the VXLAN offload, the traffic is dropped. And this line is the CPU. Because what happens is what I said, once the NIC doesn't understand what to do with the packet, is that pushing it to the software. Software means the CPU is working now for doing networking. And this is a big thing that MELLANOX is doing. And this is the other concept that I will explain in a minute, is that we think that networking should not be done by the CPU. CPU should handle application and not networking. Another offload that we are offering is called RDMA or Ethernet Rocky. Usually people are using TCP/IP, right? So if one server wants to copy to a memory of another server, what will happen is basically the traffic will go through the TCP/IP. There are many control packets running on the network to manage this protocol for drops and so on. But basically what happened is for a network operation, CPU is now used. RDMA is talking about the other thing. He's saying basically why doing that? Just go directly from the application to the NIC and copy the packet. Okay, this can be done on a NIC card that supports this feature, but from the application layer, it's kind of the same thing. Just you have the process, the memory that's assigned to the process. I want to copy this packet. I'm sending the packet. It's going directly to the NIC. NIC is sending it to another server, and that's it. With RDMA, you can reach 100 gigabit with almost zero CPU. And the reason because the CPU is just not being used. Now, this is good for physical bare metal servers. What about virtualized environment? Concept of SRIOV means that basically we are allowing such offloads to happen. The other option, let's talk about the traditional version, which is called paravirtual. It means that basically you have a simulated switch inside your VM. So you're using different kernel modules and so on, but you are still using the hypervisor to run the TCP/IP stack and other stuff to run the network. With SRIOV, what we are doing, basically you have an embedded switch inside the silicon, and we're taking the physical function, the NIC itself, and copying it between 128 to 256 times. Those are called virtual functions. And we are giving it to the VM. So from the VM perspective, he's seeing the NIC like it's here. It's physical. But it's actually a virtual function. And once we are able to get a VM, the direct connection to the NIC, then we can apply, of course, features like RDMA. And you can see that latency with RDMA is almost identical to a bare metal latency, and bandwidth is almost identical in a virtualized environment, which is very powerful. This is available when you're talking about OpenStack Inbox from Juno. We also are using the same concept of sRV and RDMA for storage. It is called ICER, and from Havana it's also part of Cinder and Nova, I think. I will not touch the storage too much, don't have enough time, but I can say that it's not only about ICER. We're doing RDMA with Ceph, for example. We're doing NVMe, which is called NVMe over Fabric. So we have many, many solutions also with other companies that are doing software-defined storage, integration with them to ensure better utilization. OVS is a roadmap item, but a very interesting one. In an overlay environment, basically you have a controller, usually maybe a VPN, maybe a controller, but anyway, you are using the OVS DB. And the OVS DB is the way to create rules. For example, VTAP is functionality that's created by OVS. OVS is still on the software. What we are trying to do now is push it also to the eSwitch, to the embedded switch on the NIC. So just about the flow on OVS, what happens is when the packet comes through, there is a rule that should be on the kernel. This is the usual way. If you have a hit on the kernel, great. If not, you are pushed to the user space and you have a big hit. So this is a hit, but this is a bigger one. What we did is add the functionality here. So now the rule will be checked here. If you have a hit, good. If not, you are going to the kernel. If not, you are going to the user space. But it's also everything is backward compatible. So it means that even if you have 0 hits here, you're still going to work in the usual way. So it's only beneficial to use a MELLANOX NIC on your system. You're going to get only benefits of performance doing that. By the way, guys, questions? Do you know what is the percentage or the market share that we are doing with more than 10 gigabit NICs, MELLANOX? We're doing 90%. 90% of the market that is using more than 10 gigabits are using MELLANOX NICs. Probably don't know that because IBM are doing it. It's just inside. IBM are doing it. HP are doing it. Microsoft are doing it. Okay, just let's see the entire picture from high level. So again, we talked about accelerations and so on and reducing costs. When you have a vendor that has the full visibility, you can build something like that or like that. I didn't mention OpenFlow, by the way. OpenFlow is also an SDN option, and it's supported by MELLANOX. And you can see here, for example, integrations in several levels of the product. The OVS offloads and offloads of the NIC on the NIC. If you want to run VTAP on the hypervisor, that's fine. If you need VTAP on the top of rack, you have this functionality. You can run Cumulus. You can run MELLANOX OS. You have Neo that can manage the entire fabric. So it's a full end-to-end solution. You don't have to use all the components, but we have all the components. Couple of words about Neo. Neo is a product that we are giving for free for a customer that is buying switches from MELLANOX. Basically, as I said, it's a software that is managing the entire fabric. It can manage MELLANOX OS or Cumulus, by the way. It also can manage other companies because it's using standard SNMP for most of the functionality. For provisioning, not, but most of the monitoring functionality, yes. Sorry. It's integrated in Liberty Inbox, so you can just open Horizon and see Neo if you would like. And basically, it gives you, even if you are running Cumulus or you don't like the concept, I don't know. Usually, when you are running Linux on a NOS, you would like the concept of Linux, and you would like to use Ansible or Puppet and manage your servers the way that you are managing your operating system on the network. But still, if you would like something to be above it and kind of have the same view and feel about all your products, you can use Neo. Neo has also integration as an ML2 mechanism driver in Neutron from Icehouse. It means that it is doing automatic provisioning on the network according to the Neutron functionality. It means, for example, that if you are moving a VM, doing VM migration, we are creating a new VM, you need to somehow create a VLAN on the network. If you don't have this, this will happen manually. Some guy would go, would just create a VLAN and assign it to an interface. If you have this, it will happen automatically. This is a huge advantage. Thank you. It means you can reduce the costs. I will finish with a case study. Before that, just another view of integration that we have in different points. So, as I said, we are integrated in the controller nodes from Horizon, Cinder, here for ICER and other storage functionalities, Nova, SRIOV. Everything is inbox. It's very important because if it's not inbox, it means that you need to go and configure something. It's an overhead. Sometimes it makes things more complex. When it's inbox, out-of-box experience, it's much more easy. We have integration with Canonical, Mirantis, HP, Red Hat. This is a real use case, a company called Sys11 in Germany. I took this use case, not because it's the biggest one, it's a deployment, but it's an interesting one. It's a deployment of OpenStack for cloud services that is working 25, 100 gig. 100 gig between Link and Spy, 25 to the servers, using ConnectX 4LX, 25 gig to the servers, running VXLAN offloads, will run once they have it, they're really waiting for it, OVS offload, Qbyte as a storage solution. They wanted to run Cumulus to have the ability to run their Ansible and manage the servers the same way as the network. They're doing that. Midonet is the SDN controller. Mitaka is the release of the OpenStack. Layer 3 from the host to the spines all the way. They wanted to use Bird. Bird is not an official protocol stack for Cumulus, yet they wanted to use Bird, so they installed Bird and it's working. Okay, this is one of the powerful things about Linux. And this is an enterprise level deployment with high bandwidth OpenStack that is working. So it's a nice story. And I will finish with a couple of some measurements that we did about how you can save money when working with the recipe that I called, the marketing name is CloudX, but this recipe that we are recommending to use. So basically, those are the same infrastructures. The only difference comes, the switches here will be 10 gig, the NICs will be 10 gig. Here, the switches will be 40 gig. And they will use, so they are a bit higher in the price, okay? And, but beside of that, everything is the same. When it comes to functionality, here we put it all the functionalities that I talked about, offloads and performance and accelerations and so on. What we did, we used the benchmark that is called SwitchBank that is measuring a transaction process with Oracle. It's just a mean, it doesn't have to be Oracle, just an easy way to measure performance. So you can see that at the beginning, let's go back, I said this installation is a bit higher in the Prost, so CapEx is a bit higher, not very much actually. But looking at the entire picture, if you are doing 750 gigabit database transaction, so kilo transaction per minute, you will see that you have many more transactions per minute. Double the OLTP performance. And if you are measuring dollar per kilo per transaction per minute, then we are 52% lower. So eventually having high performance in your cloud means less investment when you're talking about OPEX and CAPEX. That's it. If you have any question. Thank you very much.